Assalamualaikum warahmatullahi wabarakatuh. My name is Rehanah Najib binti Redan and I will start the presentation of group 13 with this circuit. This is the circuit of three-phase full bridge inverter with sinusoidal pulse width simulation control technique. Also, as we can see, can I show you the resistor? Here we have three resistors. So first, we make sure the voltage source is 200 voltage as stated in the question, and the resistor here as our load will have 45 ohm as resistance. So each will have the same resistance. This is the third resistor. Also in this circuit we have MOSFET, an ideal MOSFET as our semiconductor. So in this part, we have the sinusoidal voltage source that have 140 volt of peak amplitude, 50 Hz frequency and 0 phase angle. The next will have 120 phase angle, and the next will have 240 degree of phase angle. Here is triangular voltage source of VC with 370 V of V peak to peak, 1250 Hz, 0.5 duty cycle, and DC offset negative 185. So we also set the simulation control with its time step, total time 2.52, print time 2.5, and 1 print step. So next we can run this simulation. First I will choose BRY as the waveform, and we will adjust the x-axis. We can choose another waveform also, VC. So we can adjust both the y-axis negative 185 until 185, and also the x-axis 2.5 until 2.52. So this is the this is the waveform of BRY and VC. Next I will run it again and choose VC and BRY in a graph. We will have the same adjustment for x and y axis, negative 185. Okay, so this is the final waveform of combination waveform of VRY and VC. As we can see, the range is between 2.5 until 2.52. It's the same as this question. So next is question B. We will have the VRY. We have PWM3 and PWM6 connected to red yellow voltage, and in this part we have VY here connected with switch 6 and switch 3. I will run the simulation and I will choose PWM3 because PWM3 is same as PWM1, and this is the final result where the range is between 2.5 until 2.52 and the amplitude is 1. That's all from me. Thank you.
Assalamualaikum warahmatullahi ta'ala wabarakatuh to Dr. Nur Farahaida. My name is Nur Hamiza Amira binti Abdul Hamid, and now I want to continue to present about the result of question C and question D. So firstly, I want to introduce about our circuit. So basically our circuit is about a three-phase full bridge inverter with SPWM control technique. So from the question wants want us to use the MOSFET as the switch, and this circuit is only use R lot, which is use 45 ohm. And now I want to go through to question C. The question C wants to find the inverted PWM signal of A, which is PWM2. Before this, the question A is wants to find the waveform of VRY. So the inverted PWM signal of A is related to this one. So the inverted is means that they have the inverter. So this PWM6 is actually the PWM2. Before this, the PWM3 is the PWM1. So I just run the simulation and just click PWM6, and this is the result of the waveform. So from the question wants to see the waveform from range 2.5 until 2.52. So from here we can see that the amplitude of this waveform is 1, which is the PWM1 is the PWM2 is now turned on. So from the question, VR, if VR is bigger than VC, so the PWM is equals to 1. So this means that now the VR is bigger than VC. And now I want to present about to go through to question D, which is the question D wants to find the line voltage VBR. So from this circuit, we have voltage probe here and then this voltage probe is connected to blue line and red line. So from here, this is the positive terminal of the voltage probe, and this is the negative terminal. So this is voltage to find the VBR. So I just run the simulation and find the VBR, and this is the waveform of the result of VBR. So if and the question wants to find the range from 2.5 until 2.52 seconds. And then now from the waveform obtained, so the amplitude is from the peak to peak amplitude is from negative 200 until 200. So this means that this waveform is about three-phase waveform because have negative cycle and positive cycle. So that's all from me. Thank you.
Assalamualaikum, my name is Nurul Jannah. So now I'm going to present for the next question, which is question E and F. So question E asks us to find the waveform for yellow line current. So for this question, I put the ammeter next to the resistor 2, which is this part is for the yellow phase. So now I'm going to simulate to get the yellow line current. So as you can see, this is the waveform for the yellow current, and the waveform is for the x-axis. We set as 2.5 until 2.52 according to the question, and as you can see, the amplitude for the yellow current is 3. So next, I'm going to simulate for the next question F. The question F is to find the harmonic spectrum of VBR. by adjusting the x-axis. So VBR is at here. So I'm going to simulate to show the harmonic spectrum. To get the harmonic spectrum, we need to press the FFT. And then the question asks to adjust the x-axis, which is the scale is linear and the range is from 0 until 5k hertz. So from this we get the waveform of the harmonic spectrum, which is from 0 until 5 kilohertz, and this is the amplitude for the harmonic spectrum. So that's all from us. Thank you.